Welcome to Chapter 4, Section 2 of Algebra, Patterns and Linear Functions. We have one vocabulary word right now, that is independent. An independent variable is a variable whose value determines the value of another variable, called a dependent variable. Typically, the independent is called x, and the dependent is called y. The independent is called x and is also often the input. Dependent is y, and often called the output. Using our vocabulary, we're going to write I if the value is independent and D if it's dependent. So the growth of a plant, is that independent or dependent on the light it receives? You're right, that is dependent. Okay. The speed of a swimmer, is that independent or is it dependent on the depth of the pool? That is independent. The number of books a bookshelf holds and the length of a shelf. Well, obviously that is dependent because the longer the shelf, the more books it can hold. Another vocabulary word we have is function. A function is a relationship that pairs each input value with exactly one output value. So one of these below do not show a function. As you're looking at these, try to determine which one has your x value, your input value, going to more than one output value. That one would not be a function. You are correct. This is not a function because the 1 goes to both 1 and -1, and the 4 goes to 2 and -2. So it's not a function. So stating this again, a function is a relationship that pairs each input value with exactly one output value. Now, it could be the case that two different input values go to a single output value, and that would still be a function. But for each input, or x value, it can only go to a y value, a single y value. Here's another quick example of a dependent and an independent variable. Remember, the dependent variable changes in response to another variable, which is called the independent variable. Here's another example. The length of the shadow depends on the time of day. So your time of day is your independent. And the length of the shadow is the dependent, because it depends on the time of day. This just to make sure I'm clearing up any confusion. The values of an independent variable are called inputs. The values of the dependent variable are called outputs. Often the independent variables, which are called inputs, are often referred to as x, and the dependent variables, called outputs, are referred to as y. Another definition, a linear function is a specific type of function whose graph is a straight line. Now this line cannot be vertical, so it's a non-vertical line. But other than that, it's a straight line. In a linear function, the values of the dependent variable, remember that is your y, and that's your output, change by a constant amount as the independent, that's your x or your input, as the independent variable changes by a constant amount. So the dependent variable changes by a constant amount as the independent variable changes by a constant amount. Looking at the diagram below, the triangles ones, what is the relationship between the number of triangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. So let's take a look at this. X is going to be our input. Well, since we're looking at the relationship between the number of triangles, that's our x, so the number of triangles, and the perimeter of the figure, so that's going to be our y. Now we need to complete the table. When there was one triangle, we have a perimeter of 10. I added 3 plus 4 plus 3. When we had two triangles, we had 3 plus 4 plus 3 plus 4, or 14. Three triangles, we had 3 plus 4 plus 4 plus 3 plus 4. That's 18. And for the fourth one, we have 3 plus 4 plus 4 plus 3 plus 4 plus 4, which is 22. So So far we've done words, table. Now we need to do an equation and a graph. The equation is probably the toughest part of this to do. But we need to relate the perimeter with blank times the number of triangles plus some number. So let's look at this and see if we can come up with something. Are you thinking? Because the perimeter is 4 times the number of triangles plus 6. So y, the perimeter, remember back up here I told you the perimeter was y, is 4 times the number of triangles, triangles was x, plus 6. So that's our equation. Using the table on the previous slide, you saw that when there was one triangle, we had a perimeter of 10. So we can plot the point 1, 10. And then we had 2 triangles, we had 14. So we can plot the point 2, 14. 3 was 18, so we plot the point 3, 18. And 4 was 22, 4, 22. And as you can see, that creates a linear function because it becomes a line. In this example, we want to decide if the table represents a function. We'll then describe the table using words, an equation, and a graph. So as we look at this, does this describe a function? For every x, is there only one y? Yes. So it's a function. Why? Because as we map this, we see that each x has only one y. Now we need to determine an equation. As you can see, the equation y equals 2x plus 1 fits. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus 1 is 3, etc. And then we'll go ahead and we'll plot the points. 0, 1, 1, 3, 2, 5, and 3, 7. And as you can see, we have a linear equation, so we're going to put an arrow on each end because it has no ending. In the second example, we see a table that shows the relationship between the number of photos you take, which is our x, our input, our independent, and the amount of memory, which is our y, our output, our dependent. Is this relationship a linear function? Well, yes, it's a linear function. And why or why not? Well, it's a linear function because each x variable has one and only one. I need to say that differently. This is a function because when you map these, you can see that our x variables each go to a single y. For each x, goes to only one y. For our equation, we're going to start with 512 megabytes, and we're going to subtract the number of photos times 3. If you look at this, we start with 512, we subtract 3 for one photo, subtract 3 more megabytes for another photo, subtract 3. So that's how I get it. So this would be our equation. Now to graph this, at 0, we would go up to 512, which I have a tiny graph here, so bear with me because my pen tip's a little bit fat. At one photo, I have 509. At 2 photos, I have 506. And at 3 photos, I have 503. So once again, you see I have a linear graph. I'm going to check and see if you understand what's going on. So in this slide and the next, please stop the video, attempt to do the problems, and then when you think you've completed them, restart the video. Stop the video. So how'd you do? Hopefully pretty good. The points do lie on a line. So the relationship is, and what is it? It is a linear, it's an A, function. Okay, go on to the next slide. Do the same thing. Once you see it, pause the video, try the problems, and then check in with me. If you haven't already done so, try these problems and then check back with me to see how you did. This, of course, is not a linear function because as you can see, the x value of 1 equals both the y value of 4 and the y value of 8. And since it has 2 points, 1, 4, and 1, 8, it is not a linear function, nor is it even a function. See you in class tomorrow.